I need to check my screen. Okay, guys, you see my screen? Yep.
Yes, we see it.
Okay, perfect. So let's go very quickly. Some of the questions are, are very simple. So we don't need to do we don't really need to do that. Any questions about this type of organizing matrices? Building from pieces and creating a new matrix. This is crucial because you know what this exercise, guys, is basically imagine instead of a matrix like this toy matrix, you have data. Right? It's exactly the same. The structure and the data, like imagine Excel, it is exactly the same. You have a matrix. Then you should be able to rearrange, select, put, cut, whatever you can imagine. Any questions about this one here? Do you want to do this, or we assume we know this one?
I have a question.
Yeah, go ahead. Which one?
Like I was thinking or wondering, is everything an array?
Everything.
Like, yeah.
Everything, including words, including characters. We're gonna say it's more or less imagine Excel, one sheet of Excel. You see that you have rows and columns.
Yeah.
Now, if you have different tabs in Excel, that's exactly what we call an array. So we have one matrix, on the back of that another matrix, on the back of that another matrix, etc. So it is a, think about Excel. I always like to think about that. It is it's one Excel, a big, much more powerful Excel. Okay. Do you have questions about question number one? Everything was easy here. Yeah. So what was that? Oh, so this is an array. So let's create this array for 1 second. I don't want to. When I use semicolons, remember, guys, I don't print, and I don't want to print. So this is A1, and this is A2. Okay. So how do I know what do I have in my system, guys? What I need to write?
Whose?
Okay. So these are the two guys that I have. Now, how do you create a matrix? I don't know how do you call this matrix? An array, M1, M2. Yeah, so M is my new matrix. It's an array now. Do you agree? So how do you build your array, guys? Called M. So how do I tell MATLAB? First, A is going to be the first phase. A2 is going to be the second phase. How do I do that?
So you have to have like 3 separate spaces in your parentheses.
Right. So what I need to do is I need to tell, right? M is I need to define M as an array. The way we define this as an array is when we have 3 dimensions. These are my rows, my columns, and this is the number of phases. Right? In this case, I'm telling, please create an array and use for the first phase, use A1. Make sense? And then for the second phase, use A2. Now, if we want to see M, take a look. So now M is 1 phase, 2 phases, 4 columns, 3 rows. Make sense? Everyone was clear on that? Because we use that. We use a lot of arrays in programming, a lot. Do you have any questions about how to create this stuff? Have you created all of them? Any questions, any doubts that you have? We were okay?
I think I was okay with this part.
Perfect. Okay, so this part, yeah.
I think I coded, like, I just put M equals an array of just A1 space A2. But I think when
No,
I
no, no.
told the program that, he assumed one is a row and the other is a column. So I don't think I told it
Correctly.
to have two faces. Now that I see your code.
Yeah, so take a look to what happens if I do A1 and A2. So I will call I don't know, I will call N, okay? If I do this, if I tell N that this is going to be simply A1 space A2, so what it will do is it will concatenate two matrices. Do you agree? That's the way we used to concatenate matrices, for example. Do you see that? So it creates a
Yeah.
huge matrix.
That's what I
That's
got.
what it does. Okay, so that's why it's important for you guys. Remember to define, once you define your matrix like that, sorry, your array like that, then you can work with this array. So we'll do only one question, okay? Only one. So remember, this is a matrix concatenation. Okay, we do that a lot when we imagine we are doing simulations, and then I want to put one result next to the other, one result next to the other one, etc. This is what we're going to be doing. Okay, let's do only one. So let's assume, yeah, let's do D. Let's create M3 that contains the third column of the second phase of M and the first column of the first phase of M. Okay, let me move this to my next screen just to remember. So M3 is going to be, take a look, I will read this again. It will contain the third column of the second phase of M. So this is going to be a matrix, right? So I need to define this as a matrix. Now, the first is going to contain the third column of the second phase. Okay, so how do I call that? The third column of the second phase. So I will delete. I need to put something. I want all the rows, right? So all the rows of the third column, and the second phase. So this one here is going to be, what is the dimension of this one here? I have any rows, I have one column. Do you agree? This is going to be some 1, 2, 3. It's going to be 4 times 1. Agree. Now I need to attach next to it. If you want, you use comma or simply a space. And I need to attach next to it the first column of the first phase. Okay, so we need to, it's very simple once we understand how to read this stuff. So it's the first column. So columns are these guys here of the first phase. Do you agree with me? Okay, and then we simply, here we go. And that's the way it works, guys. And then you can compute, give me the ratio, multiply this, do whatever you can do, you know. Agree with me? Okay, so let's check another question. Oopsie, this is one. Yeah, so yeah, this is easy, right? How do you create? Just tell me, how do you create a matrix increasing 2 at a time, from 1 to 100, 2 at a time? Tell me.
1:2:100.
Yeah.
In a bracket.
And that's it. If you want, remember this, if it's a sequence, the MATLAB immediately assumes this is a vector. You don't need to have the bracket. If you do without the brackets, it's already a vector. So it's 1 to 100. Do you agree? Nice. Yeah, now what is the difference? Here I give you a specific number of observations. I have exactly 300 observations. So what do I use?
Use lens space.
Lens space. Okay, give me the numbers. Lens space, what else?
So lens space in parentheses, you start with 1, you go to 100, and the number of observations is 300.
300, exactly. Okay, it's okay. Good. Yeah, well, this is taking positions, not a big deal. This is not a big deal. Now, plotting. Plotting is very simple, do you agree? So what is that? So where is my X here? Oh. Oh, I need to define x1. Okay, so let's do just a couple of plottings. Okay, let's define, guys. Can you do this one here? Let's define x1 equals 1 to, what was the definition of x1? Yeah, I think it was in space 1 to 100. Oh, what is the definition of x? Sorry. X, oh, it's increasing x1. No, it's not in space. It's simply 1 increasing by 2 up to 100. Do you agree? This is my x1. Now, just for fun, and very quickly, you do this. I want to have 2 by 2 pictures. So you need to use a subplot. The first picture, the first one is sine of x, cosine of x. The second one can be whatever. So let's do that. The first one is going to be sine of x. The first to the left is going to be sine of x. The other one is going to be cosine of x. I'm not doing anything. I'm just writing for you what to do. This is a 1, 2. The third is going to be, perhaps let's take a look to sine divided by cosine. What is that sine divided by cosine, guys?
Dot slash.
No. What I mean is, yeah, you're
Oh,
completely right.
oh, the tan.
It's 10.
Yeah.
Tangent. Okay, and if we do the opposite, the last one I want to be cosine of x1. Oh, yeah, divided by sine of x1. And you know what? Perhaps let's define x. Yeah, that's okay. Go ahead, guys. I want the subplot very quickly. Can you do that, please? First, you need to create, let's call this one here y. y1 equals sine. y2 equals cosine. y3 equals tangent. And y4 equals the cotangent. Just do the 4 plots, please.
You said you wanted them in a subplot, right?
Yes, 1, 2, 3, 4. I want you to use the subplot structure. Ready?
Just a
So,
few more minutes.
yeah, take your time. 3 minutes. Wait, I go. Give me 1 second. We'll bring some water. Ready?
Yes, I'm done now.
Yeah, okay. Oh, so I made a mistake here. Sorry. It's not X, it's X1. So I can have all my the definition of my variables is simple, right? Yeah. Where I didn't put the semicolon. Yeah. Okay, so I have all my variables. So how do I do that? I need to do a subplot. Remember, I need to define first a subplot, right? So I want the subplot is going to be a 2 by 2. So that's the first thing you need to do, 2 by 2. And then I want the subplot number 1. So remember, in subplots you count 1 to the right 2, then you go down and 3. Do you agree? 1, 2, 3, 4. Okay, so what I want here in this subplot is what? Yeah, it created that, and I want here y1, right? Plot. I want to plot here x comma. No, it's not x. X1, y1. Let's go and take a look. Here we go. And then we start simply doing the same stuff. It's going to be the subplot position 2. It's going to be x1 with y2. I know what I done wrong again. Sorry. This is not going to be correct because this is y3. Yeah. Let me do this one again just to be sure that we have the good results. Then this one here is position 3. It's going to be y3. And this one here, you know, perhaps I've destroyed already my program, but it doesn't work. And then let's see what we have. Yeah, something like that. Yeah, not sure if the values are correct, but something like that. Do you agree? Make sense? Easy to create. Now, guys, question: when do you use a hold on? So how do you close a graph? If you want to close a graph, of course, you can simply click on the X here. But there is another way of, if you have many graphs, guys, what you do is you simply do close all. Okay, close all closes all the graphs that you have, because MATLAB creates independent graphs. Remember, it creates graphs. So now let's plot, no subplot now. I just want to do the, imagine this one here. Okay. And what I want to do is I want to graph in the same graph another graph. What I need to do? So I want this to appear, but I also want to appear, for example, the y2, the cosine.
The hold on
yes,
command?
Exactly. I need to do a hold on. And then I can tell MATLAB, okay, so this one here too. And then what I'm doing is basically that. What is the meaning of that? These are, what is that?
With the color red.
Color red. Here you go. You can see both graphs at the same time. So what you need to remember, hold on, and then you can change colors, you can change shapes, etc. What if I want to know what are
Sorry,
the
I
options
have
for
one
plot?
question about that.
Yes, go
actually.
ahead. Yeah.
So for the plot, I was curious. I tried to make one like red and change it to like crosses at the same
Yes.
time.
Oh yeah. Mhm.
But I got an error when I tried to do that. Is
Yeah.
it? Can you like show me how you would do that?
Yes, like that. You see, put the plus and the R, for example, or you do the star and the R. But this is interesting. My question was, what if I have a doubt? How can I create all this stuff? You do help plot, remember? And take a look to what happens with the help plot. It's a big, big documentation. I always like to go to the documentation for plot. Help plot, and then below you go documentation of plot. And here you have all the description, blah, blah, blah. But also you have beautiful, beautiful examples, you see? You have a bunch of things. Look, take a look. You want to do this with this one here? Take a look. All fancy things that you can imagine are here. Everything fancy that you can imagine, you're gonna find here. So that's why the beauty about the help command is, don't go to the help command. So I don't like, of course, if you want, you just go into the workspace. But it doesn't look good. It doesn't provide all the information. If you go into documentation, you get tons of beautiful examples and you see how this works, etc., etc., etc. Make sense? But normally the logic is you put whatever you want before the, for example, here you are doing, well, you can do both ways. Is cyan with a star and dots. See? You have all the options here. Make sense? Make sense, Tiffany?
Yes, thank you.
Perfect. Excellent. No problem. Okay, so we can continue with this one here. Yeah, what is the option? What happens, guys? Remember, this is a histogram. What happens when we have a histogram that has 5,000 observations, 10,000 observations, 100,000 and 500,000? What happens with the graphs?
They just get smoother, right?
Exactly. They get smoother and smoother and smoother and smoother and smoother, and they replicate more and more and more the normal distribution. Remember that? Now, how do we call these? Why I have done this 5,000 up to $500,000? Why? How do we call that? Do you remember? Imagine, guys, that we have a frequency distribution table, okay, and we have only 20 observations. Do you remember the frequency table, the relative frequencies? They are always between 0 and 1, and they sum to 1. So basically, they cannot be assumed to be probabilities, right? They satisfy the probability distribution. Now, what do you believe? I tell you guys, I have this table made of 20 observations. Can you assume the relative frequencies to be probabilities, yes or no?
No, because there are too few observations.
Exactly. Come on, it's only 20 observations. You cannot generalize with 20 observations. So what is needed in order to get this generalization? What you need to do is you need to be sure that the number of observations that support that data is huge. Agree? Now, how do we call that property? How do we call that? How do we call it? It's a theorem, actually.
Do you mean the law of large numbers?
Yeah, it's the law of large numbers. Okay, that's the law of large numbers. And you can see, guys, with 5,000 observations, the normal distribution doesn't look really, well, it looks like normal, but it has shapes, you know, it is not a smooth function. 5,000 observations already. Now, with 500,000 observations, of course, the normal distribution looks normal distribution. Got it? Makes sense? So this is the law of large numbers. Now, well, the helix was just for fun. Have you been able to get the helix?
We didn't try that one because you said not to do it.
Oh, yeah. So let's do the helix. It's very quickly. Yeah, okay, so let's define, where's my, I need to see my, I will move my assignment. We'll move this here. Okay, so it tells you, okay, let's create T. So let me clean this part. I think I don't need this part. Let's create T that is going to be, and where's T? 0 to 10p increase. Oh, so that's easy. It's going to be 0 to p divided by, increasing by T divided by p divided by 50 up to 10 times p. Do you agree? That's what they say. Create T that goes from 0, increasing by p divided by 50 up to 10 times p. Correct? It's a sequence only. So I have created my sequence. Then what we said here is the following. Create a sine and cosine function. Oh, wait a second. We haven't done the plot 3. We haven't done plot 3. Okay, you know what? Why don't we come back to this in a minute? Let's do 3 dimensions graphing. Okay, we're going to come back to this example in a minute, guys. Let's come to let's do 3D. So let me create some data. So let's assume, guys, let's create this data. Can you please create this data?
Is that the income example one?
I don't know. Perhaps yes. Yeah, basically yes. It's the income and savings. Okay, so we have two phases. We have 1, 2, 3. We have 3 individuals, and then we have 1, 2, 3, 4, 5 years. So we have 3 individuals. These are the columns. 5 years. These are the rows. And then we have income, and then we have the saving equation on the back. Okay, so this is what I call the panel data. Can you just copy this? And we're going to use this one here many times, so it's going to be okay to copy. Okay, let's say 3 minutes to copy. I'm trying to copy the exact number, so I will be able to. We are going to be able to play with this stuff also.
Professor, on the first panel data, you have a column, a comma between 82.
No problem. Yeah, no problem. Yeah, remember. Oh, whatever. Yeah, I cannot change that. So remember that comma or a space is the same.
Okay.
Okay, not with semicolon, but comma or a space. They do exactly the same.
And I just wanted to ask a quick question. If we wanted to save our script or the code that we've been writing, is there a difference between using the command window and the script, the editor?
No. You just type save and put a name. That's it.
Okay.
It saves that. Okay. Now remember what we are doing is we are starting just learning the language. We are learning words. Next class we're going to start really doing programs. When you do your own program, so everything is saved in order and smoothly, etc. Okay, guys, can you copy this and then we start working on? I will start asking you questions.
I have a question.
Yes, please go ahead.
So if I was like thinking of typing in all of the information, but then I remember that I already did it, but in another like in another workspace. So
Yes.
if I click the workspace, like the file name, and then it goes down to the workspace area.
Yes.
I don't have to like. I already taught the program what I'm asking.
The data, you mean?
Yeah, like I already like I only had to type in panel data and type enter, and it already like
It already has it.
Yeah, the format as a matrix.
Yes. That's completely right, because the program has, remember, but the issue, Luis, the thing that you need to be very careful is not to clear the workspace and not to clear the command, or save each workspace. Do you understand that?
I mean, what happens if by chance or mistake I create two same variables, like x equals 5 and then x equals 2.
No.
You know,
Yeah, I understand that. A MATLAB workspace, like any other workspace, R or Python, whatever, the current value, the last value of X is the value that is updated. All the other values disappear, all of them. Okay, so the last one is the one that is going to be the active one. Make sense? Okay, guys, are you with me? Guys, are you with me?
Yes, Professor.
Okay, so now I will first draw and then we can do some exercises here. So let's assume that X is 1, 2, 3. So these are my individuals. And what I want to see is the income per individual, the savings per individual, etc. Whatever we can imagine. Got it? So let's do this. So the command that we're going to be using, guys, is very simple. The 3D dimension command is simply called plot3. There are 3 commands that we're going to learn. Plot3. Basically, here what we need to do is what's going on here? What we need to write is what is my X. My X are going to be my individuals. My Y are going to be, imagine that I just want to have the first year. What are what is the income and savings for the first year for the 3 individuals? Do you understand what I want to do? I want to graph the income and savings of these 3 individuals for the first year, only 1 year. I don't know what I will put here, so I will delete this. So you need to do this. And these are my 1 is my income, and 2 represent my savings. So remember, my question is, guys, please graph only the first year. So the first row for the 3 individuals, income and savings. Graph that. I want to see the graph.
So it's 1, colon.
Yeah.
For So you
and
get
the other
like,
one is going to be the same, right? 1, comma. But the thing
no,
is that this one
is the second phase because it's
the second phase. Everyone is with me?
Why do we tell before the array? Why do we type in X?
Oh, X is going to be my third variable. So I want to control. Remember, I want X to represent each individual. So how many individuals do I have? I have 1, 2, 3. Okay. So I'm missing one parenthesis. Yeah. So the idea is, plot3, guys, needs 3 arguments: the X, okay, the Y, and the Z. So 3 arguments. In this case, my arguments are going to be income only for the first year. We can do more if we want. Only for the first year, the savings. And let's take a look at what happens. Oh. Oops. Oh, I know. Sorry, guys. I need to delete this one here. Yeah, so let's do. Here we go. Perhaps I can do some grid. So remember when we want to have grid on, simply makes the line, so it's much easier to see. Do you see? Now what is the meaning of that? Are you able to create this graph here, guys? And then we can play with it. So we'll show you how to play with this graph. So that the command is going to be plot 3, X, Y, and Z. Ready? Do you have this graph?
Yes, Professor.
Perfect. So now what is cool is take a look. I made it bigger just to play with that. You see that what I can do, guys, I can move it as I really want. No, what I don't know what is what. So sorry, guys. Let's put something first. Let's do X label. Yeah, X label is individual ID. Individual ID. I have my Y label. Y label is going to be income, right? Just to recognize what I'm talking about, otherwise I don't know what I'm doing. And the C label is going to be savings. And then, like all plots, you can do titles, you can do legends, etc. Ready? So now my graph is going to be the same, but with names. So this one here is my individual ID, guys. So individual 1, all these intermediate doesn't make sense. Individual 2 and individual 3. And so this way is my income, and the vertical one is my savings. So if you want to understand how this works or what is this guys, take a look. If you just move your cursor near to this part where I am, it's going to appear something that looks like that. You see? You see, just click in the one that looks like a bubble, data tips. You see that appears data tips? Just click there, and now go with your mouse until there is an inflection point here. Just click the inflection point. Now we can understand. So what is that? This is X is individual number 2. He made $72,500 income, and he saved $22,500 of that. This is during the first year. Now let's go and see to the other individual. Individual 1, he made $100,000 and he saved $35,000. And individual 3, he made $41,000 and saved $1,000. Do you agree? And then you can move this.
Sorry, can you just go back to the part where you showed your code for me, please?
Oh, yeah. Let me move this more. Here we go. It's this part, basically.
So where'd you sort of get to the part with the years? That's why I'm slightly confused. So just
what do you mean by the years?
Okay, I think I just
Oh yeah, no. You know what? Let me. I understand what the data looks like. Let me explain. The data looks like that. Do you agree? 2 phases.
Yeah.
Correct.
Mm-hmm.
Now the first phase is income. The second phase is savings. Make sense?
Yes.
Now, the X's, according to my definition, the columns are individual. So this is individual number 1, the first column, individual number 2, individual number 3. Okay, and the rows represent years. So this is these are all the individuals for year number 1, all the individuals for year number 2, etc., and all the individuals for year number 5. Make sense? So this is the way that I define the data only. I could have defined the individuals in the rows, but no, I defined this in the, that was the definition I did in the previous class. Make sense?
Okay, thank you.
A pleasure. You tell me when I go back to the graph.
You can go back now.
Perfect. Okay, you see individual number 3, during the first year, he made $41,000 and he saved only $1,000. You see that? So this is what we have here in our graph. Now, guys, what I want, listen to me. I want per individual. Yes.
Can you just show me how to locate the, I think you said it's the data tapes or something like that?
Oh, yeah. You see here, there is this small icon. You see my mouse? There is data tips.
I don't have
in the
that.
graph. In the graph. Just open the graph.
It's open.
Yeah, now you move the cursor and appears. It's a very weird. Just move it somewhere here to the right. And appears and disappears. It's weird. You see that?
Okay.
You just click on data tips.
Still don't.
Yeah, it is weird. I don't know why this version is like that. Normally this was a fix, all the time was fixed, and so you can easily click on that, but now appears and disappears. For you it's the same, right, guys? Okay, once you click on this one here, yeah, once you click, you simply go with your mouse and then you put whatever you want. So you can take a look to what is going on there. Now, if you don't like this way of seeing that, you go again to this thing that you can move. And then you can start moving as you like. Perhaps this way you prefer, etc. It's up to you. It's always, that's why the 3D graphs always are, you need to be able to move because you need to find a way in which you can explain your ideas or your findings. Make sense, everyone? Now, a couple of things here, guys. When you want to save something, there are 2 ways. When you do save as, and pay attention here, I think I mentioned this in the video. When you save this as a fig.fig, this implies that once you close this one here, you can call this figure in MATLAB and you are going to be able to edit again. Okay, now this is not efficient for LaTeX or for Word, just to copy paste a graph in your work. For that, normally what you do, guys, is the EPS or the JPG. So these are the 2 recommended ones. But once you have saved an EPS or JPG, you're done. You cannot. MATLAB is never going to open this again. It's fixed already. It's a picture. Got it? But as a picture, it's beautiful. It's much better for Word and LaTeX. If you want to modify your picture later, just save it as fig. And of course, later, once you modify it, put this beautiful, you can save this with a different name as an EPS, etc. Make sense, everyone? Okay. Now, I want you to keep this figure. What do you do if I want you to do another figure, but keeping this figure? What do you use? Do you understand? Because if I do another figure, guys, here, this is going to destroy. It's going to destroy this one because the new figure is going to disappear this one and use the space of this one for something new. What do you need to do? I want to create another figure, guys. What I do?
The command figure that
exactly
is a blank, a blank graph.
Exactly, it creates a blank space, and then you can do what I will ask you to do. Now, guys, what we have done in my plot, plot 3, is only 1 year. Now I want all the years for all individuals' income and savings. I want a graph that shows for all individuals all the income and savings for all the years.
Just like the previous code, but remove the numbers and it's all
Yeah.
colon 1 and colon 2.
Yeah, can you take a look to what happens? Yeah, you can also type it. So this is going to be column. So all the years for income and for savings. You agree? And we can do the same. Yeah, let's do grid. And the names are going to be the same. And then you can see this stuff. You tell me when you are here.
I have to figure it out.
Are you there? Are you able to find this graph? Yep. Okay, so what we can do is how do we read this stuff? So I can accommodate this one here. So guys, this is basically the following. This is individual number 1. In this axis here is its income. And the upper up going up is the savings. So you can see that this individual, you know, the height between the X and the income and the savings is a savings. You can see that the savings of this individual grows dramatically. So if you want to see the values, guys, take a look. Yes. This is individual 1. At the end, after 5 years, he's making almost $500,000 and saving 354. He was making 300, etc. You see that? And what happens with individual number 2 is this guy here. So is this part here. He also makes money, but he's not making as much money as the other guy. So the savings grow, but it doesn't grow dramatically. And this is true, right, guys? This is one of the things that Piketty was talking about, is in terms of the more the money you have, the more the savings you can do. It makes sense to you or not? Yeah, even after buying your Ferrari, your private jet, etc., you continue growing so fast and so quickly that you cannot consume everything. So what happens is that you have the lower part is for savings, investments, etc., etc. Now, there is not necessarily bad that stuff, because this money normally goes to the economy again. Got it? So, but that's the idea. Any questions about these graphs? There are a couple of other graphs, guys, that are you know, just for fun. The people some people like more this graph here, another command. Instead of the plot 3 that looks like lines, we can do the mesh. That's the only thing that changes. Oh, let's do a figure just to compare. So I don't want to disappear my previous picture. And let's do a mesh. I will not do that. You see, now you have the lines that help you better visualize the things. You see that, guys?
Yeah, it almost looks like a circus.
Yeah. Well, there is another one. that is called surface. Surf. You see? These are things that you can use and then you can play with that. So it's just for fun.
Professor, is the graph you just did now the surf?
Yes. This one here is the surf. Let me open the other one. This one here is the mesh. The mesh, what it does, it basically helps you visualize the ending points. Because if you take a look to the original one, this one here, it's very tricky, It visually looks like it does this kind of a curve. No, it's a line, but it doesn't look nice. This one here helps you better, better visualize the things. And the last one, of course, it gives you more colors, and then you can change colors, you can change whatever you can imagine later. Okay, just do help mesh or help. What's the name of this one? Oh, surf, and then you get everything. You can see all the possibilities here. Any questions? Okay, no questions?
But how, I mean, why before we had to put the number 3 after plot, but now it's only like a mesh with no numbers, like in the command.
Where?
Like in the command, at first we use plot 3, like 3 dimensions, but
yeah. No, but these ones here, these ones are commands. The MATLAB immediately knows plot 3, mesh, and surf are 3D ways of graphing. They know it. These are commands. These are words for MATLAB.
Okay.
Yep. Okay, guys, questions? Okay, so now we can do, you remember the question number, where's my question now? The helix, question 11. So I have created T already, right? Yes, I have created T. That's what I'm saying. I'm just following the instructions. Then build the sine and cosine of T. So let's do sine of T is going to be equal to the sine of T. Then I do the cosine of T, that is going to be equal to the cosine of T. Right? Yeah, I can close these graphs now. Or I can do close all, of course. Then I want to create a figure. Then I simply plot, guys. Take a look at that. This is plot 3 because it's a 3-dimension plot. And I plot ST with CT and T. Take a look to what happens. Yeah. CT, ST, and T. T is going to be my height. ST and T are going to be mixing up together. And here you go with the helix. You remember, guys, when you plot the sine and cosine at the same time, what do you get? When you do the sine and cosine?
The tangent.
No. When you plot, let me do another figure. Okay, so I will plot ST on CT. How do you call this one here?
Circle, a closed loop.
That's the
Yes.
unit, sir.
Exactly. This one here, guys, for those of you that have taken the, what is this one? Oh, give me 1 second. I don't know what I've done. Yeah. For those of you that we have done econometrics, time series models, and stationarity for process, we always talk about the unit root, the unit circle. This is exactly a unit circle. It's simply a sine cosine function. Sine cosine run one against the other one. all the mathematics are beautiful. So how do you call, why this is called the helix, guys? Do you know what is the helix?
Like the movement of a turbine.
Yes, and also in ADN, no, DNA. Yes, DNA, right? Yes, the DNA is also structured as a helix. You know, and the one that discovered the helix was here in New York. I read his book a long time ago. But basically what he was saying is he was trying to find a way in which he can represent the ADN, because the ADN, remember, looks like that, circles, two circles at the same time. You remember that? And he was saying, well, he didn't know at the time, of course. But the thing is that the idea was, in order to have that the chains all together, they need to have something like that. Got it? And the solution was this solution. So one way of representing the helix, because remember, the beauty about the sine of t, sine of 2t, sine of t over 2 is simply the frequency decreases. Do you agree? It gets thinner, it goes farther. It gets thinner, it goes farther. So you can do everything. So this one, this helix here, you can do it smaller, you can do it bigger. You know, just playing with this thing. And basically, just representing that now, the people is able to really recreate the DNA perfectly. This is a mathematical model. We are built of mathematics now. Questions, guys? Yeah, I think that let me show you the next one. I have shown you this in the class, right? I have shown you this in a video, how to do the internal rate of return, how to compute the net present value, etc. Correct?
Yeah.
That should be easy. It's nothing spectacular. What is this one here?
I had a question about the
Yeah.
one that had to do with like system.
This one?
No, further up, I think.
Oh, this one, the accounting system.
Yeah, so I was I was just slightly confused by what you meant.
Yeah, no. Here, the only thing that we want here is like the previous class. Remember, you define variables, apples, bananas, and I don't know, oranges, and then you define prices, and then you do, for example, a amount of money I spend buying fruits. So simply P times Q, correct?
Oh,
and then what I was telling to you is just now, because we don't have the program, this is going to be a question for also for the next assignment, in which you are going to be able to create a program. Okay, and the program you can do all the changes immediately. But in these cases, you need to do one by one. Okay, what happens if the price of apple goes from 1 to 2? So you change P apple equals 1 at the beginning, simply replace it by P apple equals 2. Got it? Very, very rudimentary at this point. But this one here is going to be a really cool one once we know how to program. It's going to be really, really cool because you can change parameters, you can add new parameters, and you can create basically your accounting system, your basic accounting system. Got it? But you need a program, otherwise you need to be doing this by hand. And by hand, it takes a lot of time and you get confused and it's a pain.
okay.
Got it?
Mm-hmm.
Okay. The cash flows are okay. So you understand how the cash flows work, right? The internal rate of return and net present value, that's okay. What is this one here? Oh, you need to know this. This is the payment schedule. So this is if you have a loan. Do you have any doubts about this one here? Have you been able to create your tables, etc., etc., etc.? Guys, yeah. Do you understand? Right. This is a very typical and very useful way of creating tables, guys. It's the information that you get here is information that you always use in real life. I don't see your faces as okay.
Professor, can we please do the question 16? Because I struggled to create the amortization table.
Oh, yeah. So let's take a look. Yeah, let's do that. Let's do this very quickly. It's very straightforward. So I just need to copy. Sorry, I need to copy the data. I need to move this somewhere. So I need to have, let's say I have the loan. The loan this is data. Then I have the annual, let's say annual rate. annual rate equals 4%. Where's my annual rate? No, 5%. Then I have number of years, number of periods. So let's assume this is 30 times 12, right? 12 years monthly payments. Oh, I need to have my monthly rate because this is an annual rate. So my monthly rate, guys, is a time transformation of that we have done in class. So you need to know this annual rate to the power of what? -1. Remember, what is the power here? Is a ratio.
1/12.
1/12. Do you agree with me, guys? Yep. That's what we have been doing in the classes. Okay, so I have this one here, bank loan. Yes, I have everything. I have everything. So now what we can do is I can do my principal. This is my principal payment. Principal payment. I want to have my interest. I want to have my balance. And I want to have my payment. Okay, so these are going to be the outputs of the model. The model is called amortize. And what I need to enter is the monthly. Sorry, guys, I need to enter the monthly. Where's my monthly rate? I need to enter monthly rate. I need to enter the number of periods. And I need to enter my loan. Guys, if you have the doubt of what goes into the model, you just go help amortize. Okay? Makes sense? So remember, the outputs are always with brackets. This is one thing that we're going to learn when we start working with programs. And the arguments for the program always in parentheses. Okay, so this is called outputs, arguments for the outputs, and this one here are called arguments for the inputs. So then you have everything. You have everything. So what these guys are asking you, yeah, they want an amortization table. I have the balance, right? I have the interest, I have the principal, and I have the payments. I have all. I have everything that what I need, right? What I can do is I will call table just amortization amort table. Let's see. And what I want from here is my principal. Well, it's everything, right? It's basically this part here. I will not copy everything, guys, because it's a big table. It's 30 times 12. Now, what I will do is I will take a look only to the amort table. I will take a look to the first 10, for example, 1 to 10, all columns. You see what I'm doing? I'm simply seeing from the overall table just the first 10 rows. Oh, you know what? We need to take a look to the dimensions. Size principal, I want to see what is the dimension of the principal. Oh, it is 1/360. So my table looks very long to the right. So what we need to do is let's change this one here, principal. So all of them should be that. Let's do transpose. So we transpose all of them. Because it is 1 times 360, I don't want that. I want 360 times 1. So now which one is that? The one that is not like in here. Oh, I know. Payment. Because payment is a single number. Let's take a look first to this one here. Payment, guys, you're gonna see in a minute. Yeah, now it works. So this is my, I can do a format bank. Yeah, much better, right? So I have my principal. What is this one here? No, this is not the way it works. Normally, the way it works is the following. Is this one here first? Is my balance. The principal payments, principal payment and interest payments. So now this is the way that normally we see the numbers, guys. This is my principal, my interest, and my what do you call it? My interests. Now the question that I have for you guys is at the payment. If you take a look to a payment, just type payment. It's a single number. So two things, and you need to know that. I want you to add payment to the last column. So I want you to repeat this number as many times, as many rows as we have to the right. And I want you to add to the left of the table the amount number. So 1, 2, 3, 4, 5 up to 316. You understand what I'm telling to you? So I want 1, 2, 3, 4, 5, 6 in the left, and to the right, I want this number to appear all the time. Okay, guys, 2 minutes to do this. So let's call that amortization table 2 or something like that.
Quick question, Professor.
Yes.
So from my side, my output, it puts the values to the, I think the fifth, it takes it up decimal places. So it says instead of 499, it says 4.993. How do I change that?
Oh, format. You do the format. This one.
Format.
Just type format space bank. What you have is format space long, format space short, but normally the bank is good for this one here. I prefer to use the long for other ones, but this is the way long appears. You see, mathematical notation. We don't want that. No one's going to understand that. Just format bank. Okay, 1 minute, guys. Right now. But you guys bring more in Ready, guys? Yep. Okay, so how do I do? I can do this directly here. How do I make something to be repeated as many times as I want? What I need to do?
The rep mat command.
Rep mat, exactly. So rep mat is repeat something. What I want to repeat, the payment, right? How many rows I want to repeat the payment?
360.
Yeah, but instead of using 360, I think we can use, what was the variable definition? Number of periods.
Number of period.
Yep. We can do number of periods and how many columns? One. See, do you agree? Better, guys, don't use numbers because the numbers can change, and if you're coding, numbers are very tricky to change. Always use variables like this. Or if you want something better also, guys, you know, because number of periods can change, well, but if number of periods changes, the number of rows are going to change. So this is a good variable. But also, what you can do, guys, is, for example, use the size of the original table. Do you agree? Size what? 1 or 2?
The first one for the row.
The first one for the rows. Okay, so this one is going to do that. It's going to do the, well, let me do this. And let's take a look to the first 10. Oops, what? Oh, no, so this is table 2. Here we go. You see? It works. Now, what I want from you is 1, 2, 3, 4, 5. So what do I do? I need to add something here. How do I create a sequence of 1 to 360? You know how to do that?
The 1 colon 360.
Yeah. Like this, right? But the thing is that this is also a row. So I need to
transpose it.
Exactly. Makes sense? Works or not? Well, let's take a look. Here we go. You know, mount, etc. And then you can graph whatever you want. That's I don't really care about that anymore. Now, one thing that we need to do, guys, and we use this a lot, is the financial charts. Okay, are you with me up to here? Okay, so let me close this stuff and let's do some financial charts that we use all the time. So I can do this. Now, let's do a load. There was let's load some this is data. Okay, we're gonna work later with data. Yahoo Finance works very nice. Was that simulated stock.mat, I think it was the name. So let's load this one here. So this is financial data. This is prices, price, open, low, close for stocks, guys. So you can see who's. Oh, I have. Yeah, I have. You see, it's TMW basically. I have the close, I have the dates, I have the high, the low, the open, the volume, etc. Okay, that's what we have. So now let's do only the first 25. So I have a lot of volume here, a lot of information here. I have 1,000. So let's do the first 25. Okay, so let's define range as 1 to 25, for example. This is the range is a name. I'm using the name only. And then the command for high-low is high-low. High-low. And then what we do is what we want, what stock we want, no, so it's TMW. What I want from these guys, I want range. I want all the columns. And what I want is just, black color. That's it. No, not black color, sorry. B is blue. Here we go. Make sense to you? So I have the high value, the low value, and the open, the close, okay, and the high and the low. Now there is another one that we use, guys, the Bollinger Bands. So I can use the same. So what I want is the commands here are going to be basically, I have the middle, I have the upper, and I have the lower. And this is going to be Bollinger. And I want to do the Bollinger of TMW. So Bollinger, you know what is a Bollinger Bands, guys? We take the average, the moving average. Normally the default, I think, is 15. The moving average of the data, and then we compute the standard deviations. So the Bollinger is going to be the moving averages for 15 days, 2 standard deviations up and 2 standard deviations down. Okay, so that's what we have. The middle is the moving average. The upper is going to be 2 standard deviations up, and the lower is going to be 2 standard deviations down. You're going to see in a minute how this works. So we create our Bollinger. This is data. And then we can call it, this is normally called, you can call it as you want, huh? I just put this data in a single name. And then I simply option. Yeah, allow me to do something here. I need to redo this stuff. Yeah, now I need to. Yeah, so this is going to be, guys, middle close. I will explain how this works later, okay? Upper close. Lower close, yeah, that works. So now what I'm doing is the following. I'm creating first the data. So this is the data that I will use. With the Bollinger, what I do is I create the data. So the data is here. Got it? But now, as soon as I'm using all the data, so indeed what I have is I'm creating the same for close, for date, for high, for low, for all of them. What I need to tell MATLAB is, guys, you know what? I don't care from this middle that you have, don't give me everything. Just give me the close. This is this meaning. From the middle prices, just give me the ones that are related to the close. For the upper, just give me the ones that are related to the close, and for the lower, the same. It's basically this part here. I'm saying ignore the other things. I don't care. I just want the close. Okay, so once you have that, guys, then we can do the plot. And the plot is simply, let's do middle time. Where's I want time to go down. And I want the closed volume. So it's going to be a time series, basically. Middle time, remember when I do middle, I told you it's going to do middle of everything. Middle of close, middle of days, middle of high, the low, open, time somewhere, time should be somewhere. Yeah, should be part of this TWM then. Okay, and let me see if it works. Yeah. So this is the way the Bollinger looks like. Look, the blue one is the moving averages for the last 15. This is days. Up is 2 standard deviations. Down is 2 standard deviations. That's all what it does. And of course, that the people, what they say, for example, let me open. First of all, are you able to have this graph? Yep. So what is the use of the Bollinger Band? Well, you know what? What the people start asking is, they say that normally these ones here, there are some times in which, for example, here, you see this part here, goes up, goes down, goes really up, goes really down, this goes up, goes down. This is what is called the head and shoulders. You see the shoulder here, one shoulder, one head, another shoulder. Do you see that? So this is technical analysis, guys. They see graphs. I sometimes have a hard time finding something, but there are so many of them. But this is a clear head and shoulders. Okay, so you know that this is going up, goes down. If you believe this is going to be a head and shoulders, buy here, because you know this is going to go up. The only issue is that when do you get out? Because if you get out here, you make money, right? But if you get out here, you can be losing money. However, according to the head and shoulders, even if you get out for here, you still make money. You see that? That's technical analysis. So we're gonna do some technical analysis later. Make sense to everyone? Okay. And the last one, guys, this is a really important one, the candle. So let's do CMW. The last 20 observations, okay? And minus 20, just to end. All columns. And let's do this blue. Look, guys, you're reading this way. Do you know what the end command does? It gives you the last row. So it says the last row minus 20 to the end. So this is the last 20 observations. Do you agree? And simply the candle produces is a plot and give me the color blue. Perhaps I can create a figure, just not to delete your one. And here we go. So first, be sure that you can open this one here, and then I will explain you what is the meaning of that. Are you ready, guys?
Got the figure.
Yeah, so I can tell you more or less what is this one here. So the ones that I white are good days. So what is a good day? The open is below, well, it's not a good day, it's simply the open below the close is white. Now, the blue ones, the open is above the close. You see that? And the lower is the minimum value and the upper value. These are the candles. Do you see that? Do you understand that? Well, you can see that the variation in this day here is amazing. So this is white. So this means that the open was basically almost the same as the close, but the close was still higher. But there was a huge variation in prices. There was a huge volatility of the market this day. Now, in here, for example, how do you interpret this one here? It was a bear market or a bull market?
A bear one.
Yeah,
Bear. Bear, because the open was up and the close was down. Do you agree? And also there was a huge drop in prices.
Way low, yeah.
Right.
But that means during the day it got to that point. Yeah.
This is a single day. You can see the price changes. I'm going to from 162 to
So the
105.
close, sorry. So the
Yes.
close was still higher than the lowest.
No. Oh, yeah. Yes. The close was still higher than the lowest value of the day. Do you see that? Guys, make sense?
I understand it.
Perfect. Okay, guys. So I think with this one here, we have all the graphs that are important for finance. We're gonna do more of them later, okay? But if you don't have questions, so we can continue. We can continue volume runs, whereas I should not forget. So we have done, let me see the exercises. Yeah, I think with this one here, we are done, right? So any questions about number one, assignment number one? It is easy, guys, but you need to practice. Getting familiarized with these changing matrices, everything. You're gonna see how this is gonna be working later, but it is really important. Okay, no questions, so we can continue. Yeah, I don't want to express. So now, guys, let's start working a little about with texts. Okay, so let's type. Can we type this one here? So I have this type here, right? Can we just type that one? Now, guys, what is really interesting about MATLAB is that for MATLAB, everything is mathematics. Got it? And remember, indeed, that's the way the codes work. Everything is mathematics. Okay, the binary system, everything is mathematics, based on mathematics. The computer understands only binary. That's the issue. Now, MATLAB only understands mathematics in terms of vectors and matrices. So, for example, if I want to select only this character, only this part here. So I need to take from position 1, 2, 3. Space is also another a character. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. From 16 to 17, 18, 19, 20, 21, 22, 23, 24. So if I want to do E, select only 16 to 24. You see, for MATLAB, text is exactly the same as a vector. Can you write character starting from R? So shift character. So I want RETC, the first part here, just for fun.
Can we transpose you?
No, because
Or
it is
maybe-
not a transposed, it is a change the positions, remember. I
Oh,
want
can
the
we
last
do
position to be first.
the end
Yeah.
command? Yeah.
Yeah, do it. Can you do that?
Let me
Let's call this U1. Is it going to be U or what?
Wait, so just to confirm, are we trying to reverse the letters, all the characters in the string?
Yeah, no, only this one here. So I want this to be the first one to be R-E-T. I don't know what letter is going to be. Simply R goes first, E goes second, T third, etc.
Okay. So would that just be end
Yeah.
and
End.
then colon -1
Yeah,
and then colon 1?
yeah. You agree? The same thing, guys, that we have done all the time. Now, what is interesting also is that MATLAB uses the ASCII code A, B, C, D, E, F, G, for example. Okay. What we can do is the following. Let's call this M equal apps. Oh, sorry. M equals apps of S. Take a look. So apps of S, this is something we're going to use a lot, guys, on symbolic mathematics, okay? This transformation of letters to numbers. When we do polynomial optimization, you're going to see this is very handy. So apps, this is a new word that you need to learn. Apps also means absolute value, by the way. But when you apply apps to a string, it simply transforms this string into its ASCII code. So if you do Alt 65 in your computer, what are you going to get? A. Alt 66, you get B, etc., etc., etc.
Prof, can I just take you back? How does MATLAB identify that U is a string?
Oh, because it's defined by a string by these ones. Two things. By this one here.
Mhm.
So even if I write a number in a string, in what they call apostrophes, for MATLAB, this is a string. Got it? And in MATLAB, you cannot write the string without apostrophes. So if you write without apostrophe, MATLAB is going to collapse. They don't understand that. You need to tell them, hey, guys, this is MATLAB. Now, let's call this S1.
Wait, sorry, what does apps give again?
Oh, apps transforms every single string into its ASCII number. ASCII is that, do you remember, I don't know, well, in USA, you don't have special characters, but in all different countries, we have different characters. For example, the tilde, you know, in Spanish, we use one special character is a small line that goes on certain words. Okay, this is a special character. So you normally, if you want to type, you do Alt in your computer, and you type 65, and then you get A caps. You can try that if you just open Word. So let me create a new open Word. Yeah. Here, you see my Word.
Yes, I could.
What I will do is I will press Alt 65 and I get the A. You see what I'm saying? Alt in your keyboard. Don't just continue pressing Alt and type 65. And that's what you get. Alt 67 is the C. You see? So each letter in the alphabet plus special characters, they have an ASCII code. Make sense? And then basically MATLAB, what it does is that it determines ASCII code, knows ASCII codes of every single character. There are not many, there are only 256, I mean. Okay, what is interesting is this one here, set a string. I will set a string of M. So now what you can do is the reverse. If you have strings, you want to make an ASCII code that are numbers, you use apps. Now, if you want to go the reverse, numbers to strings, simply set a string. And then you recover the letters. Make sense?
No, may you please just explain again what we're trying to do here?
Oh, here what we're trying to learn is how to move from strings to numbers and from numbers to strings. So you see, this is a string. I can transform that in numbers. And then if I have numbers, I can transform them again in strings using this command here. You see? So string, numbers, string. Simply going back and forth. So now let's do a game, guys. Imagine that G for me is hello. Okay, and what I will transfer to you guys is G1 that is equal to G plus 5. Okay, have you seen what happened here? As soon as G is a string, but I have added a number, MATLAB immediately transforms this G from a string to a number. Now, can you read this one here? What is this one here? How do I read this one? How do I read this message?
Would you have to do the set string?
Yeah, exactly. So I will call this G2. It's going to be set string of G1. Wow, it's MJQQT. Now, I want you to recover my original hello. Now, guys, do you remember there was a... Have you watched The Beautiful Mind?
Yes.
Yes. Okay. So the code, basically, the movie is fantastic because it's a real person, Nash. The thing is that all the movie is about deciphering codes. Okay. And MATLAB, by the way, in around the 60s, 70s, when they disappeared, was also used to create codes. Of course, what I'm doing here is something very simple. So if I give you this number, guys, I will give you this part here, and I will give you this number. Guys, 5. Can you recover? Imagine that you know that you need to do the -5. Can you recover the message? Can you recover my hello? Do you understand? So what you receive from me is this gibberish. But I'm telling you guys, you know what? It's simply 5. How do I recover it is my G plus 5. So how do I recover my hello?
you subtract 5 from the G2, and then you will then set string the new G3.
Do you agree? And then I do G4. You can go back and forth as you want.
But why, when we do G minus 5, it doesn't go back to 109, 106, and then it still reads
Can
low?
you repeat that?
Like when we did the G2 minus 5, it went 104, 101 instead of 109, 106, which is
because
our original message.
No.
Like
the original one. No, the original one. If I want to see the original one, let's do apps of G. This is my original one. G2 is not my original one. G2 is already transformed. G2 is already based on this number. That is already transformed. You see that? The original G is this one. The original is hello. If you want to transform the hello into numbers, they match exactly the same numbers as before.
That's correct, yeah.
Make sense? Perfect. So now, guys, let's assume sometimes this is useful when you're working in the following way. So imagine that I have x equals, I will set strings, okay? Year 2014, 2023. Sometimes I have data like this. Where's my mouse? I will just copy. And I will transpose this one here. Oh, sorry. Yeah. Sometimes, guys, when you work with the census data, for example, they always have these funny ways of you have a TXT format, and the TXT format has joined together letters with numbers. And you know, you cannot do anything with these things here. You want just the year. Okay? I just want to have the year. So what I will do, guys, well, easy, right? What I can do is I can create X1. And X1 is going to be, from X is going to take what? Position 3 to 6. 3, 4, 5, 6. Yes or no? Upside. All rows, columns 3 and 6. Basically, columns, every single character here is a column. So I obtain my 2023. Do you see that? However, guys, take a look to whose. So, let's do whose and take a look to X1. X1 is still a character. I want this to be a number. Okay, so here it looks like a number, but when you have the apostrophe, it means that it's not a number. It means that this is a character yet. So how do I transform this one into a number? Well, let's compute, let's do YY equals a string to num. And what was the name of my variable? X1. Now I have a number. Now, this string to num, guys, is extremely useful when we create repetitive processes. For example, I want to replicate 1,000 times one process, you agree? And I want to save the results every time. Imagine my results, I want to be called results. But you know that if you call results, it's a file, you know, a CSV file or Excel file. When you run 1,000 times, what it's going to be doing? It's going to take the first one is going to be results. The second one is going to delete results and it's going to create new results. So at the end of the 1,000 iterations, you're going to have the last iteration results only. But I don't want that. I want to have 1,000 files with 1,000 iterations. Got it? So normally what we do is iterate results_1, results_2, 3, 3, and 1,000. Do you agree? So when we have these type of things, the string to num is going to be fantastic. Okay, I will show you, but just remember, string to num, what it does is it transforms strings into numbers.
Can you scroll just to like it's the start of this?
Yeah. Here we go. This part here is a mixture of letters. You see that, the YYs, with numbers. And I want to extract only the numbers. You see that? And this is if you see a service guide, service always have this particular way of doing that. They do DD number, MM number, YYYY number. So you want to extract only the numerical part of that particular cell. The way you do that is basically, this is a character or a string. You simply take the values that you want, not this one. Take the values that you want. However, you need to be very careful that these numbers are still strings or characters. They are still like that. So you cannot work with these numbers. So if you want to transform these numbers, these strings into numbers, what you need to do is you need to use a string to num. And these numbers are numbers. So you can take a look. So let's do a whos. And we're looking for YY.
I understand that part. I think I was just a little confused about how we picked out the number specifically. So can you just scroll up?
Yeah. The number is where is this one? Here we go. This one.
So X1 first, wait, the last three.
Yes, here.
Rows.
Remember, this is 1, 2. No. Remember for MATLAB, this is row 1, row 2, row 3. You have 4 rows, okay? So that's why I say all rows. Now, what columns? Well, for MATLAB, this is the first column where we have a string, second column, third column, fourth column, fifth, and sixth. So what I'm saying is take the columns 3 to 6. This one here. You see, just extract the numbers that are the portion that is a number. And so we have these ones here.
Okay, I understand now.
Questions? Easy, right? Don't worry, guys. We are going to get familiar with all this stuff. Remember, also what is interesting about the summer classes, guys, is you need to learn so much, so fast. What I believe is that we have now the recordings. That's beautiful. Because when you review, you can say, I don't remember this stuff. Go back to the review, and I'm pretty sure, go back to the recording, you want to be able to remember and practice better. But questions at this point, guys? Yeah, okay. There are other commands that are basically good for timing. If you write in MATLAB today, have you seen this also in Excel? When you go format number in Excel, you obtain something similar. It doesn't tell you anything, right? What is 73, 90, 28? I have no idea what is this one. So the command that we use, guys, is date string of today, for example. Now you have something that you can read. However, guys, remember that when we do programming or models, it's much easier to work with numbers than to work with this type of variables. First of all, in terms of if you are using a lot of simulation takes a space. This one here at least takes 3 times or 4 times more space than this one here. So that's good for you if you do simulations. Just use the numeric representation of the things. The double is the cheapest variable that you have in the systems every time. Everything that is a string or character, guys, it consumes a lot of space of your computer. Well, if you do small programs, you don't realize that, but if you do a lot of simulations, use the number representation of that. Okay, so we have today. We can do also, this is something called now, but you don't see anything with now, data stream now. So we are, 7:54:34 seconds. There is another one that we always use. We try to do. Let's take a look to this one here. For example, I want to see all the Mondays. I want to see all the Mondays. So this L week date uses 1 is Sunday, and then you go 2 is Monday, etc., etc., etc. And I want all the Mondays, the first Mondays of each month of 2023 for all the months. So this L week date gives you, the last Monday, well, in this case, the last day of a month. So in this case, I'm saying, give me the last date, the last day, what day, Monday, what year for all the months. Well, unfortunately, this is also with well, I should do this to you. So these are numbers. So how do I recover that one here? By this one. We'll call it Mondays equals set a string Mondays. And then you can see much better. These things we can take a look. Yeah, the other one that we use is also interesting, the holidays. And the command is, of course, holidays. From when to when, guys? 1 Jan 2023. Let's say until 31st Dec 2023. So these are all the holidays that we have. Now we can write holidays. We do this like that. It's going to be date string. Call date, etc. And then you have it. So these are all what?
Professor?
Yes.
Does this database only cover one country, or can we get data from different?
You can. You can different data, but you need to find the libraries. Yeah, you can. Okay. Just go on the dates. Sorry, what is my holiday? Holidays, help holidays, and then there are codes, special codes for it per country.
Okay.
Okay. Well, I think that one is good now. Bonds, yeah, the bonds is easy.
Can you show me the one you used to get the Mondays?
Yes, here we go. Is the last, so last, this L means last Mondays. There are a bunch of other commands that you can take a look later. Business days, of course, holidays.
Wait, so what does can you just explain what these numbers in the parentheses?
Yes, of course. Yes, so this L comes from last day, okay? What day? 2 is Mondays. 1 is Sunday, 2 is Mondays. Got it? So
Yes.
what I want is the last Monday of 2023, all months. So if you want, imagine only from January to March, 1 to 3. That's the meaning of this one here. Okay, so there are more complex ones, but they are useful. For example, Martin Luther King dates. Oh, where's my mouse? Martin Luther King. Let's assume. So this one here is N week. So if it's not the last week, you need to use this N week date. Okay, what day do you want? No, sorry. Martin Luther King is the third week, right? It is the third Monday. The third Monday, let's say 2016 up to 2023 and January. This is Martin Luther King, right? It's the third Monday of each year, right? So this means the following. This is what week of the month? Third. What day? Monday. For what years? For which month? Yeah, and I need to. Mistake here. Here we go. So it was 18 January, 16 January, 21 January, 20, 18, 16, 17, etc. So these are the specific. These are the, so 16 January this year was Martin Luther King. Make sense? Okay, so enough language for today. So let's do something more interesting now. Yeah, this is crucial now. Do you understand this part here?
Yes, I understand that.
Yeah, okay. So now, guys, let's go into something that is called relational operators. So in relational operators, guys, we have, of course, the ones that you know, this, smaller, equal, greater or equal. Then we have equals. Okay, when we are relational, guys, we use 2 equals. Okay, we don't use 1 equal. When we have a relationship, when there's a logic command, we use 2 equals. At not equal, so let's see. And we have the last one here that is not equal. So it's a tilde equal. So we're going to use all these three guys. So these are also called logical operators, okay? You're going to see how powerful these operators are. Okay, so let's assume, guys, that I have A equals 1 to 9. Very simple. And let me define B equals, let's say 9 minus A. Are you with me? Okay, so now what I want you guys, let's call it TF equals, I want to tell me, so let's do first A. Let's take a look to A. So this is A. So I want you to tell me what values are greater than 4. So I will say TF, identify from A all the values that are greater than 4. Okay, so let's run this one here and take a look to what happens. So what MATLAB does is 1 by 1 says, are you greater than 4? No. Greater than 4? No. Greater than 4? No. Greater than 4? No. Greater than 4? Yes. 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 So this is this part here. Make sense? So it returns a Boolean is 1 or 2. No, sorry, 0 or 1. So this one here is useful, guys, for dummy variables, for example. You know, I want to select dummy variables. I want to put 1, 1, 1 for June, July, and August. All the remaining ones are 0. Make sense? Okay, so let's assume, another one can be, let's do TF1. I want to know A. Tell me if there are elements in A that are equal to elements of B. And this is something also that it is really crucial. When we do, so imagine, guys, the examples I'm doing are very small, but the small can be millions of data sets. At the end, I will show you, if we have some time, the data sets that I work with. So it have at least 250 rows and at least 3 million observations. Okay, so 250 rows, if you want to see visually one with the other one, even Excel is not able to capture that. It's not able to open this type of data files. Okay, so MATLAB is able to do that easily. It's nothing. For MATLAB, I work with 7 million rows at a given point in time with 500 columns. MATLAB was like nothing. The problem is a computer. You need to have a very powerful computer. This laptop, guys, it doesn't hold that. But if you have a very powerful PC, it's nothing. Okay, so you see why I'm saying that we need to use equal, equal? Because if I do equal, so MATLAB is going to say, wait a second, you cannot have 3 equalities here. This equal is an equal of equal, and this one is a logic equal. So what we're saying is, TF is going to store all the logical values of this equality, if there is any. I have none. Do you see that? That's the meaning of zeros. Okay, you tell me, guys, what I'm doing here. I will put A, and I will put B. Oh. Yeah, you don't see that. But basically what I'm doing is, what is this part doing? Where's this? This is going to be what?
You're saying CF2.
Yeah.
Oh, I don't see it. It's B minus if A is greater than 2.
Yes. So basically what is going to have B greater than 2 is going to have 0, 0, and 1, 1, 1 after that, right? You agree? So what is my B? My B is this one here. So what I will do is 8 minus 0, 8, 7 minus 0, 7, 6, here I have a 1, right? 6 minus 1, 5, etc. Make sense to you? Okay, you can do funny stuff here, guys. Okay, so now let's go into more funny stuff. Can we do the following? So let's define H. I have panel. Oh yeah, I have the panel. Do you have this one here? Yeah, but I want just to have, no, I will do something similar, something simple. Let's assume, guys, that I have H. Let's type this together, okay? So we have, let's assume 21, 18, 25, 19, 22, 23, 17. So these are the ages of people. So let's do format long, just not to have the 000. So these represent ages. Got it? Can you please add the ID of the individuals to the left? And the ID is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can you create a matrix that is called ID age that has the ID in the first column? That is simply 1 to I know how many numbers, and the age is here. Ready? So this one can be from 1 to something transpose comma age. So what I write here?
1 to 7.
Yes, but I don't want to use 7. I want something that represents 7, but not 7.
Can we do end?
End of what? Because end needs to be related to something.
End of the array age.
Yes, but no. But there is a command, the size. Do you agree? Size of h, comma 1. What is going to give me? What is this size of h, comma 1? It's going to give me always the size of h. So if now it's 7 and we do 100, it will be moving immediately. Agree? Here we go. Everyone is with me. Do you understand this part here? This is something we always do, guys. Huh? I will do one example, and you're going to do at least 4 or 5 by yourself. You're going to see how easy is this one here. Now, guys, let's do okay drink. So let's assume that we are interested about the people from my sample that is able to drink. So remember that the condition is that the person should be older, 21 or older, right? Correct? Yes or no? And I want to basically, I want you to tell me how many people can drink in my sample. How many people can drink in my sample? I do this one with you. Okay, so first of all, I will use the information on IDH, correct? Now, what I'm interested is what? All rows. I will check every single row. MATLAB, you need to check every single row. But then from this every single row, you need to check what? I just want to see what? What column? What column is the one that has the age?
Second one. Age.
The second one? Yes. And what I'm looking for? I'm looking for people older or equal than 21. Do you agree? So what is this going to provide? It's going to be 1 for the first, 0, 1, 0, 1, 1, and 0, correct? Yes or not? So basically what I'm telling you is this one here. But this is not what I want. What I want is you to tell me how many people is able to drink. So what do you do?
You have to sum.
Yeah, easy. Do you agree? Because these are ones and zeros. These are numbers. So what I will do is I will simply sum this one. How many people do you have in your sample? 4. This sample can be thousands of observations. We don't care. But that's the idea. It's very simple. Now, what I want is I don't want to see that
Can we go back a little to the
Yes.
point where we put the identifying number columns?
This one. This one?
The one before.
Well,
this one. Actually, this one. Where
this
we
one is the
created
complete one.
the IDH. Yeah,
yes, this one here.
That created. Yeah.
Oh, when IDH is created, this one here.
Yeah, like I'm trying to type in and it's giving me an error.
No, perhaps take a look. It must be is one, so it's a bracket. Two brackets. This bracket here is for the complete matrix. You have another bracket for the sequence, and then you go 1 to size of h comma 1. You should have defined h first, right? Otherwise, if you don't define h, nothing exists.
Yeah. I created the h.
And then you need to transpose.
Matrix. Yeah.
Transpose. I need everyone to be here, guys, because otherwise we cannot do exercises.
Yeah. Okay, now I got it.
Yep. Okay, then what I've done is basically, is this one here. I want you to tell me how many people in my sample is able to drink. Basically, what I'm saying is I'm identifying, this one here provides a 0 ones. From my all the rows of IDH, second column, that is the column that contains the ages, are older than 21 years, older or equal than 21 years old. So it's going to give me these numbers. But I don't want the numbers, I want the sum. I want to know how many of them. We simply sum them. Got it? Make sense? Okay, so now, question. Yeah, now I want to know the ID of the people that is able to drink. So basically, I want to know which of these individuals, 1, 2, 3, 4, 5, are the ones that are able to drink. So let's do okay, drink ID. So this is going to be my variable. $15 more minutes, guys. Let's go. We are almost there. Okay, I do this and then you do the others. Okay, so now okay to drink ID. So now what I want, first I want information from this guy. Do you agree? What information from this guy I want? What rows I need? I need the column number 1, correct? That contains the IDs. But what rows? The rows that satisfy only a condition. What is a condition?
If the age is greater or equal to 21.
Exactly.
How come you're saying you're looking for because it identifies with column 2, but you wanted to output column 1 with that?
No. Column one is the one that contains the IDs. Do you agree?
Yes. So in order for it to identify the ID, it needs to go check the age.
It needs to, yes, completely right. Completely right. So basically what I'm saying is, okay, give me this one is IDs. Which rows I will give you? Give me just the rows that satisfy this condition. Okay? The rows of IDH, the second column, are larger or equal than 21. And this is going to give me individuals 1, 3, 5, and 6. Make sense? So now what if I want not only the ID, but I want the ID and the age of this individual. So I want to know how old is individual 1, how old is individual 3, etc. What I do.
Instead of putting 1, you'll put colon.
Yeah, give me everything. Here we go. Individual 1 is 21 years old, individual 3, 25, etc., etc., etc. Let me create.
So
Yes.
let me get this straight. We asked, like when we did the column 1, we just wanted to know, like yeah, at the end we just want to know which of the participants were of age, and then
21 or older.
Or older, yeah, with the condition. And then on the second one, we use the same condition but for all columns.
Exactly.
So it gave me the the identification and the age.
Exactly. Exactly. All the people that are older than 21 years old. They agree?
Yeah.
Make sense?
Okay. But then how, I mean, I wonder.
Yes.
How did the program know what was the variable okay drink ID?
Oh, here.
Before we taught it to it.
No, it doesn't know anything. The program doesn't know anything. You need to tell them what is the definition of okay drink. This is my definition of okay drink. Do you agree? Is a number, is the rows that satisfy this condition. So the rows, sorry, yes, is the rows. Is check every single row, column number 2 of this variable, of this matrix, sorry, that satisfy this condition. Remember that column number 2 of the matrix contains the ages. You see that?
Yeah.
Okay. Okay, so now let's create another variable. I have gender. So let's assume 1 is male, 2 is female, okay? Can you please create a matrix, another matrix, ID, age, gender? That is going to be, that is going to contain the 3 variables. It's going to contain ID, the age, and the gender.
Prof, could you just repeat what you want us to do?
So what I want is the age. Sorry, I want you to create a matrix that has ID, age, and gender. So this is my gender. 1 is male, let's say, and 2 is female. You can call it reverse if you want. It doesn't matter. So basically here is 1, 2, size, let's say age, comma 1. I need to transpose this one here. Then I need to join age and join gender. Do you agree? So this is your new matrix. So we have the ID of the individuals, we have the age of the individuals, and then we have the gender of the individuals. Okay? Okay, 3 or 4 exercises before we go. Okay, guys. Now, question for you. I want you to tell me the gender of the okay to drink guys.
Can we do the same code as before, but
Yeah.
but at the
So-
end, just like do the condition greater equal than 21 for all rows?
Yeah, okay, so it's okay, drink, what I say, females? Oh, I say something.
Just said the gender, you didn't specify
Oh,
gender.
oh, gender. Okay, so now be careful that it's not anymore the IDH is ID, the matrix is IDH gender, right? This is the new matrix. And from this IDH gender, I want, yeah, check the second one, everything, and what I want here. I don't want everything. I just want the third column, right? Make sense?
Yes, Prof.
Okay, the last one, guys. Okay, so let's see if it works. Yeah, it works. Agree? Now, can you give me the complete information set? So basically, or no, not the complete. I just want the ID and the gender of the okay to drink guys. Only the ID and the gender.
Can we do like right after the 20, the greater than greater equal than 21, just position 1 and 3?
Yes. So needs to be brackets 1 and 3. Here we go. You agree? Okay, guys. So we stop here. I think we have done a lot. I will, as soon as we have the recording, it's 4 and I need to ask, we are very lucky because we are before the regular classes. So that's why these guys can provide us with a recording very quickly. Normally they take a week by experience, normally it takes a week for them to upload this stuff, but we're good. Okay, I will give you also the next assignment is not due for next month, for Wednesday, it's due for next week, but you can take a look and you're gonna see how interesting is knowing this stuff and managing this stuff. Okay, guys, sounds good?
Take care.
Prof,
Yes.
was exercise 1 due today?
The exercise number 1.
Okay.
Yeah, I give you until tomorrow. So if you give it until tomorrow, you can do that. Okay?
Okay.
But normally try to do this the week. I use the weekends for practicing because that's the best time you can do for practicing, guys. Next weekend you're gonna have 2 assignments. The one that I will give you today and another one, but they're easy if you practice, but you need to practice and do that. Got it? This is cool. It's really cool. You wanna see how the computer does different things that you really like, and then you're gonna see that. Okay? See you guys.
Thank you, Professor.
Bye.
Bye.